Alright, final exam review. This will be problems 1 through 10. Look, if you're just trying to watch this video and then doing the problems as I go through them, that's not going to work very well. What you need to do is work the problem out and then check your answers. So, number 1, this is adding complex numbers. Pretty simple, we just add like terms. So, 5 plus 1 is 6. 7i plus 1i, 8i. The only thing different here is if this was a subtraction problem, you would need to distribute the negative to each one of those. Number 2, negative 6 plus 4i, negative 5 minus 3i. Same type deal, combine like terms. So we have negative 6 plus negative 5. So negative 6 minus 5 is negative 11. 4i plus negative 3i, so 4i minus 3i is 1i. So I'm just going to put an I there. All right, so that's how you do those two with adding complex numbers. Number 3, this is multiplying. The way that you can tell that this problem is multiplying is because there's no sign in between. Up here, there's an adding sign. Right here, there is no sign in between, which means we need to multiply them. We're going to multiply using box method. Negative 6 and I, 5 and I. So this is negative 30 minus 6i, positive 5i, and this is I squared. One thing I hope you remember is I squared is negative 1, so this is actually just a negative 1 right here. Combine like terms, and then you actually have like terms right here as well. So negative 30 minus 1, negative 31, negative 6i, and 5i minus 1i. Okay, so remember the I squared is a negative 1. Number 4, dividing complex numbers. 3 over 9 plus 3i. There are two terms on bottom, okay? So we need to multiply by what's called the conjugate. Conjugate just means change the middle sign. So now we need to multiply this out. I'm going to distribute across the top. 3 times 9, 27. 3 times negative 3i minus 9i over, on the bottom, I'll do box method. Something really neat happens with conjugates, and that's why we use them. Watch what happens here. So we get 81 minus 27i plus 27i, and then minus 9i squared. Well, look at what happens on our diagonal. Positive 27i minus 27i. Those two cancel. I squared is negative 1, so this turns into a positive 9. Negative 9, negative 1, so 81 and 9 make 90. Now, check all three numbers. What goes into all three of them? 9, so we're dividing the entire thing by 9. 3 minus I over 10 would be your final solution for number 4. Remember, you got to check all three numbers. On number 5, negative 10 plus 8i over 5i. This time there's only one term on bottom. So we multiply top and bottom by I. So on top we get negative 10i plus 8i squared. On bottom you get 5i squared. Remember we talked about this. This is a negative 1. That's a negative 1. So now what I have is negative 10i minus 8 over negative 5. I do not want to have, the real number needs to go first. And since they're all negative, we're going to make them all positive. 8 plus 10i over 5. If you did not understand the stuff that I just went over, go back, look for videos. Adding complex numbers would be number 1 and 2. Multiplying complex numbers would be number 3. And dividing complex numbers with 2 terms on bottom would be number 4. Dividing complex numbers with 1 term on bottom would be number 5. Number 6 says solve using quadratic formula. Let's be real. If this is on the test, solve it any way you can. If that means plug it back in or solve it a different method, it really doesn't matter. Just make sure you can solve these. In quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. Okay? So on number 6, we have 2r squared plus 2 equals 0. A is 2. There's not a middle term, so b is going to be 0. C is going to be 2. So negative 0 plus or minus square root 0 squared minus 4 times 2 over 2 times a, which is 2. Now I'm going to do the inside of this piece first, so I'm just going to type the inside in, not the square root, just the inside. 0 squared minus 4 times 2 times 2. I get negative 0 plus or minus the square root, negative 16 over 4. That 0 is a 0, so it doesn't matter. Now, if you remember, if there's a negative underneath the square root, that means we have an I. So right now I have plus or minus I squared root of 16 over 4. But we have to simplify the square root of 16. Square root of 16 is just 4. So I have plus or minus 4i over 4. 4's cancel. This makes plus or minus I. And that's your solution for number 6. Problem 7, I'm going to start working a little bit faster. A is 6, B negative 9, C is 12, negative 9 plus or minus square root. Make sure that you put that in parentheses right there, otherwise that's going to cause some things to get messed up. Okay, so you have 9 plus or minus square root. And then under the square root, we end up with negative 207 over 12. Okay, so 9 plus or minus I square root 207 over 12. We need to check 207 to see if it has any solutions. So 207 divisible by 3, so that's 3 and 69. Then that's 3 and 23, and 23 is prime. So that comes on the outside. 9 plus or minus 3 square roots, 3i squared root of 23 over 12. Check the numbers on the outside. What goes into 9, 3, and 12? 3. So this turns into 3 plus or minus I square root 23 over 4. Had to divide the entire thing by 3 because everything had a 3 in common. Okay. The thing with number 8 is that we need to get it set equal to 0 first. So we need to subtract 3n and add 12 to each side. So we have 10n squared minus 3n plus 12 equals 0. So a equals 10, b equals negative 3, c is 12. Set up our problem, negative 3. Simplify what's on the inside, negative, so that makes that a 3 plus or minus square root negative 471 over 20. There's a negative underneath, so we need to take out an I again. 3 plus or minus I square root of 471 over 20. We need to check 471. So that's 3 and 157. 3 doesn't go into 157. 4 doesn't. 5 doesn't. I don't believe 6 does. Try 7. 7 doesn't. 8 doesn't. 9 doesn't. 11 doesn't. Okay, so that's going to be the end of that road. Nothing pairs up. So that is going to be our solution. All right. Looks like I'm about to run out of time on my video, so I'm going to get through number 8 on this video, and then I'll pick up at number 9 on the next one.